second part of carry look ahead adders. In the last presentation we found that Ci is equal to Gi or Pi Ci minus 1. This was the equation that we found, and we already know that we are going to use this equation to predict the carry, and the prediction of carry is the everything in carry look ahead adders. So at the start of the addition you are having the number A, the first number, you are having the number B, the second number, you want to add both of them. You are having C minus 1, which is the carry input to your first half adder. Okay, if there is any carry from the previous additions, then it is the carry. So by using these three informations, we are trying to calculate the sum and the carry as soon as possible. So let's use this equation. If I put I equal to 0 in this equation, then let's see what we are having. We are having C0 equal to G0 or P0 and C minus 1. Okay, let's say this is our equation 1. Now in the next part we will put I equal to 1 in this equation. So we are having C1 equal to G1 or P1 C0. Why 0? Because I is 1, so 1 minus 1 is 0. Let's say this is our equation 2. So what we want? We want all of our carries C0, C1, C2 and C3 should have the carry C minus 1 on its right hand side, so that we don't have to wait for any carry to come out. This is something we have already discussed in the first part of the CLA. Okay, so in our first equation we can see that C0 is having the carry C minus 1 only on the right hand side, but in your second equation we are having C0 which is not C minus 1. So what we will do, we will put the value of C0 which is Z0 or P0 C minus 1 here and try to simplify it. So let's do it. C1 equal to G1 or P1. From the first equation we are having C0 as Z0 P0 C minus 1. Okay, and once you open the bracket you are having G1 P1 G0 or P1 P0 C minus 1. Now you can see that the C1 is having only carry C minus 1 on the right hand side. Okay, so we don't have to wait for any carry to be evaluated, and we can directly have our C1 because C minus 1 is something we are having at the beginning of our addition. So we can directly put C minus 1 here and we are having C1. We don't have to wait for the first adder to evaluate C0 and then the sum CS1 and then carry C1. So this is how the CLA works. And now let's put I equal to 2 in the equation. So C2 and GI is there, so G2 or P2, and at this time we are having C1. So again we have to put this thing because it is equal to C1 instead of this C1. So let's do it. C2 is equal to G2 or P2 and the C1 will be replaced by G1 or P1 G0 or P1 P0 C minus 1. P1 P0 C minus 1. A very easy calculations we are doing. Okay, so the next step is to open this bracket, and by doing that we are having G2 or P2 G1, this is G1, P2 P1 G0. Let me slide the board, and the last term will be P2 P1 P0 with C minus 1. So again you can see that the C2 is having only carry term C minus 1 on its right hand side. So directly putting C minus 1 we can have our C2. So what we are saving, actually we are saving some time. And how it is done, let me show you. This is your C minus 1 directly fed to your first half adder. These are your two numbers A, B, definitely the first bit of two numbers, and then you are having sum, and after all these things you are having your carry. So if I want carry from this adder, I have to wait all the way until this adder has given the value, and then only I am having the carry here from this adder. So we have to wait for some time because the gate inside this adder will take time. But by doing this thing, by using this equation, once I am having C minus 1, I can directly have C2 at this point, because C2 is given by this equation in which we are having C minus 1 and none of the other carries C0, C1 involved. So we are saving time. So the last thing is to find out the value of C3 in terms of C minus 1, and I will get C3 when I put I is equal to 3 in our general equation that we evaluated in the last presentation. So C3 is equal to G3 or P3 C2. So let's do it. It is G3 or P3 C2. Now we will do the same thing that we are doing from the last three steps, which is replacing this C2 by the value in which there is only C minus 1. So let's do it. C3 is equal to G3 or P3. This whole thing will come in the bracket. So G2 or P2 G1 or P2 P1 G0 or P2 P1 P0 and C minus 1. Now let's open the bracket. G3 is there, P3 and G2. P3 P2 G1, P3 P2 G1, and this will be P3 P2 P1 G0, P3 P2 P1 G0, and the last term will be P3 P2 P1 P0 and C minus 1. So this is the value of your C3, and this was the value of your C2, this was the value of your C1, and this is the value of your C0. So you can see that all this C0, C1, C2 and C3 is having only C minus 1 as the carry term in its right hand side, so it can be evaluated directly. So what we have to do, we have to implement this circuit so that we are having our sum and carry. So let's do it. I have already made the circuit, only thing is to paste it down. This is the circuit, the CLA logic. This CLA logic is all the equations that we evaluated now. These equations, this one and the two other ones are inside this CLA logic. So what you need G3, P3, G2, P2, G1, P1, G0 and P0. Now you already know that your G3 is equal to A3 and B3, the generating term that we evaluated in the last presentation. Similarly, your P3 is equal to A3 XOR B3, okay, and your P2 is A2 XOR B2, P1 is A1 XOR B1, and P0 is A0 XOR B0. Fine. Now in this circuit you can see that your sum 3 is what? It is equal to A3 XOR B3 XOR C2. So here we are having C2, this is your C2, this is your C1, this is your C0, and C minus 1 is there, and this one is your C3. So we can have our sum as 3 directly because A3 and B3 is already given in the question. A is your A3, A2, A1, A0, and B is your B3, B2, B1, B0, the 4-bit 2 numbers that we want to add. So this information is already we are having. So A3 XOR B3, and C2 we evaluated in terms of C minus 1, and C minus 1 is already available to us C minus 1. So I can have C2, because in C2 G2 is A2 and B2, that's already available to us. P2 G1, P2 P1 G0, P2 P1 P0. So all this thing is there from the beginning of the problem. So I can have sum 3 directly. Similarly, sum 2, sum 1 and sum 0. And C3 is also only dependent upon C minus 1 and also the XOR and AND combination of these bits. So C3 is also directly available to us. So you can see that we don't have to go to that cycle that we did in the full adder. We are having our result directly as soon as we are having the problem. Definitely these gates, XOR gates and AND gate, will take some time, their delay, but definitely this time is much smaller than the time taken by the full adder. So you can analyze this circuit, you can make this circuit in your exam, and this is all you need to know about the carry look ahead adders. Actually, this is the complete information that is required at this stage of time. So this is all in this presentation. In the next presentation we will see another arithmetic circuit.